Hi, welcome to this Get Connected with Machine Learning with Nordic Semiconductor. So I hope you've had a great virtual conference with Edge Impulse so far. So we'll just go through the agenda first. So we'll talk a bit about who we are, both the presenters and then we'll have a quick glance into what Nordic Semiconductor does and our history. We'll then take a look at what we offer in terms of hardware, software development kits, tools, etc. And then we will be spending the majority of this session looking into machine learning and Bluetooth Low Energy, as well as machine learning and cellular IoT. So who are we? My name is Bjørn Spokkeli. I'm a senior project manager in the applications department at Nordic Semiconductor. So I'm managing projects related to prototyping platforms, development kits, and other proof of concepts. And I'm been at Nordic since 2015.
Yeah, and my name is Martin Lesund. I work as a technical marketing manager, focusing on cellular IoT. And I actually started out same as Bjørn Spokkeli in a tech support group actually, and I worked 3 years there as an application engineer, focusing on 9160 and cellular specifically. So now I work more with customers, meetings, collateral material, and that kind of stuff. Yeah, I think we can get started.
Yes. So Martin will be joining us for the latter part of this presentation, focusing on cellular IoT. Let's start a bit with an introduction to Nordic Semiconductor. So we are a fabless semiconductor company founded in 1883. Our headquarters are in Trondheim, Norway, with a lot of R&D centers scattered around the globe. So just to sort of explain this fabless expression, so this means that we don't own our own foundries. We buy the manufacturing services of silicon foundries, mainly TSMC, and then we collaborate with distribution partners like DigiKey, Maser, and similar distributors to get our chips and products out to our customers. So today we are just above 1,000 employees, where around 75% of that is R&D. So in 1983, we started as a ASIC company designing application-specific ICs for NRFE customers, so designing the chips from the bottom up and providing them with the IP. Since then, we've moved over to creating off-the-shelf components, and we've become a specialist in low-power wireless connectivity and embedded processing. Currently, we are a market leader in short-range IoT with our Bluetooth Low Energy and multi-protocol solutions with a decent market share of around 40 to 45%. And we have also been an early mover into cellular IoT with our low-power LTE and NB-IoT technologies. So our cellular chips are mainly being designed in our Finland and Sweden, or in our Finland R&D centers in Oulu, Tampere, and Espoo, and as well Turku. While the Bluetooth Low Energy and sort of short range products are mainly designed in Trondheim and Oslo. And lastly, we've also expanded our product portfolio into Wi-Fi connectivity. So we hope to bring our sort of low power speciality into Wi-Fi connectivity. So expect to see some new products for Wi-Fi coming in the future from Nordic Semiconductor. Yeah, and other than that, we also have sales and support offices all over the world. So if we take a quick look at Nordic's product portfolio, so I want to emphasize that this is a sort of a snapshot. We also have a lot of other products, but these are sort of the flagship devices and the most popular ones. So when I joined the company in 2015, we just launched the NRF52832, and before that, we had the NR51 series and sort of decades of low power connectivity experience before launching that product. But after the sort of the founding member of the NR52 family, the NR52832 was launched, we have the family has grown considerably since then with more cost-specific and sort of smaller ICs in the 52805, the 52810, 811, and the 820, which all focus on different sort of segments and applications, to the more advanced 52840 chip and its little brother, the 52833. Quite recently, we also launched our first dual-core SoC, which is the NR5340, which we will be talking about later in the presentation. On the low-power cellular side, we have currently only the NRF9160, which is our system in package, which Martin will talk about in detail further or later in the presentation. But this is supporting LTE category M and NB-IoT, and it also has an integrated GPS receiver. While all our short-range SoCs support close to any protocol operating in the 2.4 gigahertz spectrum, so Bluetooth, Thread, Zigbee, proprietary protocols, and Matter, etc. Lastly, we have also begun releasing our own complementary ICs for the short-range SoCs, which mainly consists of front-end modules to increase range and connection robustness, and power management ICs to increase the battery lifetime and of our devices. So these are complementary devices that you add on to either the NR52 family or the NR53 series. So we could talk about the sort of features of the NR52 family for quite some time, but we will focus this presentation on the NR5340, which is our flagship device when it comes to short-range connectivity. So as I mentioned in the previous presentation, this SoC has a dual core, so it's a dual ARM cortex-m 33. One of them is a dedicated application core running at either 128 megahertz or 64 megahertz. We will talk a bit about this flexibility in the next slide. And then we have a dedicated network core running at 64 megahertz, which handles all the wireless or runs the wireless protocol stacks and handles all the radio-related functions. The NR5340 has an extensive peripheral set, USB, quad SPI, NFC, close to any serial interface, you can imagine SPI, I2C, UART, I2S, PDM, PWM, analog to digital converters, etc. So if this device doesn't sort of tick most or all of your boxes, I don't know which device from Nordic Semiconductor that will fit your applications. But as I said, it has a dedicated network core that has a low power 2.4 gigahertz radio that supports Bluetooth 5.2. So this includes Bluetooth direction finding, which allows you to determine angle of arrival or angle of departure. It includes Bluetooth mesh. But the radio also supports 802.15.4 based protocols like Zigbee, Thread, Matter. And as with any of our wireless SoCs, you can also create your own proprietary protocols that communicate between Nordic devices. In addition to the extensive peripheral set radio and dual arm cores, we also have advanced security features. So the application core has trusted execution with ARM Trust Zone. We also have an ARM crypto cell unit that allows for advanced cryptography and also enables hardware root of trust to ensure that you're protected from malicious attacks or people trying to break into your system. And this hardware root of trust system is sort of rooted in this secure key storage unit within the IC. So the nRF5340 has these duo M32 ARM cortex-m cores. So the application processor is sort of the high performance core with DSP instructions and floating point capabilities. It also has 1K of flash and 512Ks of on-chip RAM. So here you can sort of clearly see why this particular SoC is kind of perfect for these machine learning applications. You have a very decent or a high-performing MCU core with lots of on-chip flash and RAM for your application code and the machine learning models. The other core, as I said, is a dedicated network processor, but it is very important to note that this is also fully programmable. So if you want to offload certain tasks to the network processor, because when this core is running wireless protocol stacks like a Bluetooth protocol stack, for the majority of the time, you will only be using a fraction of the total processing power. Maybe just 10 to 20%. So the rest of the processing power you can use to offload the application processor and run that at full throttle, doing inferencing, running the machine learning model or any other type of task without really interfering with the wireless connectivity, as this is completely independent from the application processor. If you would like to dedicate the application processor to only running the machine learning model, you can offload the sensor data collection or any other task to the network processor as well. So when you're starting out with the development on the nRF5340, we recommend that you use the nRF5340 development kit. And this is also supported in Edge Impulse Studio, so you can build your own or test and train your own machine learning models and deploy them to the nRF5340 development kit in Edge Impulse Studio. If you haven't sort of seen Nordic's development kits before, you'll know that they have all their I/O pins and interfaces routed out to connectors. We also have a Segger J-Link onboard programmer and debugger, so you don't need any programming or debugging hardware in addition to this kit in order to program and debug your code. We also have user programmable LEDs and buttons that can be used for user input and user output. The kit also has support for current measurement. So if you want to profile your application or machine learning or the NR5340 running your machine learning model, doing inferencing, that is also possible, and you can sort of profile and ensure that you get the battery lifetime that you want with your application. In terms of power supply, the NR5340 accepts a wide voltage range, and it also can be powered through USB and external power supply, LiPo batteries, or a simple CR2032 coin cell battery. So we've now talked about the hardware, so the NR53 IC and the development kit. So now we'll look a bit into the software development kit from Nordic. So this is called the NFConnect Connect SDK. This is a single code base and toolchain for our NRF91 series, the NR53 series, and the NR52 series. So it's one SDK for all our devices. The SDK is built around the Zephyr RTOS kernel, which is part of the Zephyr project maintained by the Linux Foundation. So if you look in the figure to the right here, you see these purple boxes. That's parts of the SDK that are part of the Zephyr project or other open source projects, while the blue boxes are the Nordic specific additions that are added sort of alongside the open source components of the SDK. So the SDK itself contains application code, connectivity protocols like CoAP, MQTT, which then runs up on top of UDP, TCP, etc. We also have wireless protocol stacks for Bluetooth, Bluetooth Mesh, Thread, Zigbee, Matter, etc. So if you look closer at these blue boxes down in the right-hand corner, you see that Nordic sort of concentrates on providing sort of the low-layer modules that sort of interface with the upper layers that are part of the Zephyr project. And then we add our own samples and demos on top of the Zephyr project's modules. And not to forget, this SDK also supports development for cellular IoT, so LTE-M and narrowband IoT, which mainly uses UDP or TCP and protocols based on top of that. The SDK also has sort of comes fully integrated with sort of code management tools like Git, build tools like CMake, and configuration tools like device tree and and these sort of provide a great flexibility for developers. So even though the SDK sort of looks large and consisting of multiple repos with a lot of modules, in terms of configuration, there's a very large flexibility for the developers to choose the modules that you need in your application and sort of peeling away the ones that you don't need. So when you want to get started with the NRFE Connect SDK, you are so welcome to install it manually, but we also have something called the toolchain manager. So this is a cross-platform tool for Windows, Linux, and Mac OS, and it simplifies or automates the installation of the NRFE Connect SDK. So as mentioned before, the SDK is sort of uses Git as the code management tool, CMake and Ninja for the build system. Python is also used, and a lot of other third-party tools. So what this toolchain manager essentially does is that it installs all the third-party tools for you, clones all the NRFE Connect SDK repositories, and sort of sets up the SDK with a single button press. And once it's installed, you will be given the option to either use Microsoft Visual Studio Code as the editor, or you can use the Segger Embedded Studio IDE to develop your code. For this session, we will be using Microsoft Visual Studio Code when we're doing the hands-on. So if you want to take a look at the toolchain manager later, you can find the link to the documentation here in this presentation. But I'll also show this in the demo later. So in Microsoft Visual Studio Code, we have created an extension, which is called NRFE Connect for VS Code. This is built from the ground up for a tight integration with the NRFE Connect SDK. So without this extension, you also be using the command line interface to build and flash the samples. While the NRFE Connect for VS Code extension comes with a lot of nice sort of added features and that provides sort of ease of use. So we have graphical user interfaces for building, flashing, debugging, and configuring the samples. There's also a wizard for creating your own custom board and integrating that with the SDK. And as you probably know, Microsoft Visual Studio Code is also cross-platform, so it's supported on Windows, Mac OS, and Linux. So we've now spent quite some time sort of looking at sort of the offerings from Nordic from a sort of general perspective, the hardware that we provide, and the software tools, and a bit about Nordic's history. But now we'll be talking about machine learning within the NRFE Connect SDK. So in the latest release of the SDK, we've made it easy to integrate edge impulse machine learning models into an NRFE Connect SDK application. So I assume that most of you are sort of familiar with Edge Impulse Studio, where you sort of build and train your model and deploy it to the supported boards. But at some point, you want to put your machine learning model into a real product, into a dedicated application. And if you're doing that on Nordic hardware, you will either be communicating with over BLE or through the cellular network. So we have multiple samples geared towards that. So we have sort of samples that are relatively simple. So starting with the Edge Impulse Wrapper sample, which is more or less what the name implies. It's a wrapper API that allows you to run machine learning models from Edge Impulse inside an NRFE Connect SDK application. Then we also have the Edge Impulse Data Forwarder, which allows you to capture data from sensors that are not supported natively in Edge Impulse Studio. And then we have the NF machine learning reference application, which we'll talk about in detail in a later slide. So let's start with the Edge Impulse wrapper. So as I said in the previous slide, this is a wrapper implementation for running Edge Impulse models in NF Connect SDK. So it's very easy to set up. So once you've set up your machine learning model, captured test data and trained your model, and you want to run that on Nordic hardware and sort of kickstart your product application, you simply need to perform sort of two steps. You provide the URI and API key to your Edge Impulse model in the configuration of the sample, and then you define the input data that will be processed by your machine learning model, and you are ready to go. So what this wrapper example also does is that it automatically downloads the machine learning model directly when you build the sample. So the build system will fetch the application or the deployed machine learning model as a C++ library and integrate it into the application and build it along with the other with the NRFE Connect SDK application. The classification results are then logged over UART, and you get the results shown there. Yeah, and the documentation to this particular sample is in the link below. Then we have the data forwarder. As you may know, Edge Impulse has this data forwarder protocol that allows you to capture data or to send data from sensors that are not natively supported in Edge Impulse Studio to the Edge Impulse ingestion service. And you can then use that data to train and test your model. So what it essentially does is that it forwards the data over UART to this data forwarder daemon, and that sends it up to the ingestion service of Edge Impulse. Then we have this complete reference sample. So once you have your sort of trained machine learning model where you're satisfied with the performance, you can then sort of take a look at the machine learning sample and use that as a reference. So this is a completely modular and event-driven sample based around our event manager and module and the common application framework. So the block diagram looks rather complex, but what the common application framework essentially allows you to do is sort of to strip out the modules that you don't need and only keep the ones that you would like to use. So this machine learning sample uses the Edge Impulse wrapper module in NRFE Connect SDK. So it imports or downloads the Edge Impulse C++ library. The wrapper allows you to run the machine learning model, and then events are propagated through the event manager, and you can then get real sensor data and run inferencing on that, and then transmit sort of the results or the data over Bluetooth Low Energy or through the serial interface. So then the plan was to demo this Edge Impulse wrapper sample in NRFE Connect SDK. So here I have the toolchain manager of our NRFE Connect SDK. So I won't go through sort of the installation process. That is something that you can look up yourself when you get started. But once the latest version of the SDK is installed, we simply click Open VS Code. And if you haven't installed the NRFE Connect extension yet, you should of course do that, but for this presentation, I have, of course, installed it from beforehand. So let me remove this. So if I open the welcome page, you will get instructions on how to use this, this extension. But now we want to open the wrapper sample. So I'll click on this, add an existing application to the workspace. And I then simply navigate to the folder where I've installed, where the toolchain manager has installed the NRFE Connect SDK. And I can then navigate to the samples folder, and we will then find the edge impulse samples here. So these are the data forwarder and wrapper samples. If we go back and if you want to run the machine learning sample, you'll find that under applications and here at machine learning. But what we want to test in this session is the wrapper sample. So we'll select this folder and open that. We'll now see that the wrapper sample is added here in the applications window of the extension. We haven't added our build configuration now, so we should do that. And since we've been talking a lot about the NR5340 SoC, we want to build it for that. So I'll select that board. And you simply click Generate Config. So we can now see that the extension is setting up the configuration and building the sample. So we now have a, or we'll soon have a configuration. At least we should have. Yeah, so the when you configure the sample for the, or set up the build configuration for the first time, it will also automatically build the sample for you. So this seems to take a little while. So let's just wait for that to finish. So while it's building, we can scroll a bit up in the build log here, and we can see that the build system is downloading the machine learning model directly from Edge Impulse Studio using the URL to the model, or URI to the model that is specified in the configuration. So we can see that over here. So if you look at the input files and this PRJ config file, we see that the link to the particular model that we are fetching is here, and that's what's being fetched automatically by the build system, downloaded, and the zip is extracted, and the build system then builds the or integrates the C++ library into the application. So the configuration is now done, and the sample has been built. So we can take a look at the source code here. So if you take a look at the wrapper sample, it uses, it has a pretty limited API. You initialize the wrapper, and you provide it with some input data that is provided in this input data header. And once we've now built the sample, we can also flash it to one of the connected devices, which is NR53, which is the NR5340 that is connected to my computer. So if I click build here, oh, sorry. Yeah, now we're building the sample again. We wanted to flash the sample. Yeah, so now it seems that the sample is building again, so we can take a look at this at the model that we are that we're downloading from Edge Impulse Studio. So we have several public models that are used by our samples. So this particular, if a particular signal is a sine wave, triangle wave, or just sort of an idle signal. And the raw data that we are using inside the sample or using as input to the machine learning model is sort of fetched directly from. So we can, for example, click this square sample and copy the raw data. And when we then go back to the wrapper sample, we can then define the input data here in this header file. So I've already copied it into the header file here. We now see that the sample has been flashed, and we can connect to the terminal, and we can see the inferencing results. So what we're inputting now to the machine learning model that we downloaded from Edge Impulse Studio is this sine wave data, and we're running it through the machine learning model, and it correctly classifies it as a sine wave. So we can try to comment out this particular input array and provide it with a square input signal. And this should then be treated as an anomaly, as the machine learning model isn't trained to detect a square wave. It will detect it as, or should detect it as an anomaly. So if you then click flash again, this will build the sample again with the new input data, and we should be able to see the new inferencing result based on that new input data. Well, it could seem that my computer isn't playing along for this particular demo. So instead of using up Martin's time, I think we can switch over to machine learning and cellular IoT, and then we can try to do this afterwards if we have the time.
Sounds good. So if you can, I can share the screen. Let me see.
Yeah, let me just leave and then you can.
Sure. Yeah, so I'm trying to share the screen, but I cannot hijack it while Björn is connected. So there's some technical issues here, but let's give it 1 minute and see if we can get up the presentation. Doesn't seem like I can share my screen. Could I maybe get some help from our host? There we go. Now I can share the screen. Great. So there we go. You should be able to see the screen now. So now I'm going to talk about the NRF 9160. This is something I think is very interesting. It's our cellular IoT device. So if there's 3 things that you should remember from this presentation about the NRF 9160, is that it's low power, easy to use, and it has a tight integration. And what we mean by this is, first of all, the NRF 9160 was developed from the ground up to be low power. And also we have used low leakage processes in our development. And also we have, of course, optimized the radio performance from the hardware side, but also from our improved modem firmware that we release. And for ease of use, you want to have a product that is easy to use for developers. So we made this NRFE Connect SDK to be very simple to use, and we have different tools. For example, NRFE Connect for desktop, which are complementary tools that work with our devices to make it easy for developers to use and develop on our platform. And of course, the NRF 9160 is globally certified, and with tight integration. What we mean by that is it has an unprecedented level of integration. It has a complete communication and application module inside with all the relevant components in a 10 by 16 by 1 millimeter system in package. So we're going to look on the device now. Here it is, the NRF 9160 system in package. So this is based on our Nordic system on chip approach. We have the ARM cortex-m 33 microcontroller unit with its dedicated flash and RAM, so you can program your devices on this MCU. And we have a multiband LTE and NBRT modem that we have developed with GPS support. And of course, we have this small form factor. And inside the system in package, you can actually see that we have the power management IC, we have all the passives and crystals that you need, and of course, it's dedicated to RF front end. And in the middle here, you see the NRF 9160 system on chip, where we have the MCU, cortex-m 33 with trust zone, RAM, flash, all the peripherals, UART, SPI, I2C, you name it, supported. And you have, of course, 32 GPIOs available to program and connect to any device that you need. And of course, the modem, which is supporting LTE and NBRT, as well as GPS. It's, of course, ultra low power. That has been in the Nordic DNA for a long time. And of course, we want this on our cellular devices as well. So we have an average current consumption around 18 microamps at 81.92 seconds in EDRX intervals, and a PSM floor current of 2.7 microamps. And that is for the whole system in package. Of course, it's multiband support for global coverage. You can use this device all around the world as long as you have network coverage. And it's a pre-certified system in package. So what is LTE and NBRT, and where does this lie in the cellular IoT space? So it was introduced in the 3GPP specification release 13 as specified for low power IoT devices. So It's also future proven. It will be a part of the 5G with regards to their focus on massive machine type communication. There lies the LTM and NBRT technology. And of course, they have also critical MTC and enhanced mobile broadband focus. That is different technologies that is not focusing on low power devices as the NRF 9160 is. So if you're creating a new device that is supposed to have cellular connectivity and low power, we really recommend to use LTM or NB-IoT. For example, 2G and 3G is getting its sunset and shut down around the world, and we see that they are not low power, of course, and we also see that this is being shut down more and more now. So you really should focus your new products on these technologies. Yeah, so what's the difference between these two technologies? So LTM, has a bigger bandwidth compared to NB-IoT. You also have a larger throughput compared to NB-IoT. And it's the range of NB-IoT is longer from the base station. And also NB-IoT has higher penetration, so it's more suited, for example, inside or under concrete with regards to the signals being sent back and forth from the base station. With LTM, you have native support for mobility. That means reselection between the cells when you move devices. So, for example, for asset tracking applications, LTM is probably more suited because of this. And also you have support for roaming with LTM that is limited on the NB-IoT network. And the battery life between these two technologies is around 15 years if you have optimized your application correctly and have and you're using the correct hardware. And as Björn mentioned, we have our NRF Connect software development kit, and this I'm not going to go into details. I just want to highlight the figure on the right-hand side here, which is the separation between the modem core and the application core and what is running on the different things. And on the modem core, we have the modem firmware that we develop, which is a binary blob that you can flash. And also it's possible to do firmware over the air with modem firmwares. And on the application core, you are running the NRF Connect SDK with all your drivers, libraries, and your application on top of that. And you enable what you're going to use in your application. We have support for MQTT, CoAP, lightweight machine-to-machine, HTTPS, etc. And of course, we have robust and flexible firmware over the air with application updates over the air and also modem firmware over the air, and also full cloud and application examples in our SDK. So Nordic owns the whole solution. That means simple support. We have our own dev zone, which you can get in contact with our technical support if you have any questions with our devices. And since we have made all the things, it's easy for us to support you, and it's easy for you to get support because you only need to talk to us. So you can focus on your own application. And now a little bit about the two different development methods I'm going to talk about. Here is the 9160 development kit. It's supported already on the Edge Impulse Studios. You have all the IOs available as our other DKs. You have the onboard debugger programmer, and we have 4 user programmable LEDs, as well as 2 buttons and 2 switches that you can program as you want. And we have also some power consumption pins here you can measure. You can measure the 9160 system in package. So for example, we have developed the Power Profiler Kit 2, which is a measuring tool that you can connect to this DK to measure power consumption. And we also can measure the SIM current consumption here. And we also have USB connection for debug and programming at the top here, as well as the UART is communicating through the virtual COM ports. So this is typically very recommended when you develop your cellular IoT applications. And for prototyping, we recommend this Thingy 91, Nordic Thingy 91. It's a battery-powered small device. I have it here, so it's quite small. And on the back, on a PCB, you have all the kinds of different sensors. You have environmental sensors of different temperature, humidity, accelerometer, you have light sensors, you have even a buzzer, and of course you have the 52840 as well on this board that acts as a board controller, but you can also use this to communicate with other Bluetooth low energy devices, for example. So then you have a cellular IoT gateway. So you can communicate with different devices and send that data directly into the cloud through LTE or NBRT, for example. And you have the reference design online for free, the open source code, of course, which is on our NRFE Connect SDK. And that's a very good starting point for making prototypes and machine learning application, for example. So this Nordic Thingy 91 is soon getting support on the Edge Impulse Studio as well. And now over to the different tools we have. Björn has already talked about the toolchain manager, which installs the whole NRFE Connect SDK. And we also have the Power Profiler application, which you use together with the Power Profiling Kit 2, which is shown on the right-hand side here, which you can do to measure and get a very high accuracy to find any inconsistency in your application, and you can really power optimize your device while doing current measurements. And we have also the online power profiler, which is used to estimate power consumption for your cellular IoT applications. This is a free online tool which is running on DevZone site. So if you go on there, you can select your network, and you can also set different parameters. And for example, if you're going to send 1,000 kilobytes of data each hour, how long you're going to sleep in power saving mode, and at the end you get an estimate of the total power consumption you're going to use in that specific network parameters that you have selected. So this is a very easy and a great and quick tool to use to find out what your device is actually using before you actually test it. And to test it, of course, we recommend tools like Power Profiler Kit 2. And what's is really nice with our NRFE 9160, we also have the NRFE Cloud, which has a lot of cloud services, which suits very well with our 9160, which, for example, have location services and also firmware over-the-air services as of now. But we are coming with new services as the time goes on. Yeah, so I have sped up the presentation a little bit just to make sure that I managed to show off the demo, because I think this is a really interesting demo here. So first, to just set up the scenario, we are going to use a 9160 DK. I have it here. And on top of the DK, we are using the X-Nucleo MEMS expansion board that's just placed into the Arduino Uno form factor. And we are going to use the accelerometer on this expansion board, and then we're going to send this data. I'm going to record over the LTE network up to a MQTT broker, and for this example we are using the HiveMy MQ broker, which is public free. And yeah, let me just get ahead and show it. So yeah, so first I went through the Edge Impulse tutorial on recording the measurements from the sensor here. So I tracked 13 minutes of different movements. So it's up and down, wave, and also we have the snake, and also the idle mode when you just have it still. And then I also added in some anomaly detection. If it sees something that it doesn't recognize, you get a signal to the server about that. And then I just went on deployment, downloaded the library, and I have flashed this firmware here that is made by Jan in Edge Impulse. So this is hosted on GitHub on Edge Impulse firmware NRF91. And you also have a description on how you can flash this to the device. And this is an application that is based on one of our samples in NFConnect Connect SDK, the MQTT simple sample with some modifications. So basically, I just went on GitHub here and downloaded this and added this into the NRF Connect SDK, and basically just dragged and dropped the model I have downloaded from Edge Impulse Studio into the application, and then I just flashed it to the NRF 9160. It was a very simple process, and it's very easy to use. So if you have a 9160 DK, I strongly suggest you to try it out, because it was a very fun and great learning experience for me as well, to get to know and use this Edge Impulse Studio. And so now we're just going to showcase this. So I take up the serial terminal here. Let me just reset the DK so you can see it's working. So first off, I'm going to connect the NRF 9160 to the LTE network. I just send a NFConnect Connect 80 command to do this, and waiting for it to connect to the network, and then it's connected to the MQTT broker. So I have set up the broker here, and to run the machine learning sample, I just send a new AT command, run AT plus run impulse. And now we see that it's starting to sampling from the device and sending it up to the broker, as you see here. So now the device is just standing still on my table here, so that we see it's getting idle. So remember, this is data that is sent over the LTE network over to this MQTT broker here. So if I start to move this device now up and down, we see that the device recognizes this and sends that to the MQTT broker. And if I wave, we should see that as well. Yes, it works. I've trained the model very good, apparently. And now we do the snake and see if it recognizes it. Yeah. So I just do the movement as a snake and it sees it. So let's try to do something else. I just shake it very much and see if it recognize this. Okay, so now we get the anomaly. So the algorithm, the model I've created, doesn't recognize this, and it sends that to the cloud. So I think I used 10 to 15 minutes to go through the Edge Impulse tutorial, and also to just flash this device. And it was very simple and easy. So if you have a 9160 DK, please try this out, because it's a very good learning experience and a nice way to get to know the Edge Impulse Studio as well. Yeah, so that's my demo, and I guess that's about our time limit. So if we have any questions, I guess we can do those now. Or if we don't, we can maybe say thank you very much. Let's see. Yeah. So I think we can just end this presentation. I just want to thank everyone that watched, and thank you, Björn, as well, for your first part here.
You're welcome. Thank you for doing the final part, and for
great stuff. yeah, I guess we end it there. Have a nice day.
Bye bye.